This is my work. I know. What did you have it?
Okay. So have you guys seen domain and range before?
Isn't that like the one with like the number line and
Yeah.
between the 2 points, the range, and then the main is
Kind of, yeah, just like domain is like left to right, all the way across left to right, and then range is up and down. And you
Oh.
have like the number line. So it sounds like you have at least heard those words in math context before, which is good. Okay, so I need to teach you something really quick before we can do this lesson totally right. So, the practice assignment is a worksheet. It is blue. It's a blue worksheet. Okay. So I have to teach you something, and you don't have to write this down because it's like all of the chapter 3. All of it. Okay.
learning all of it.
No,
I
I do
think
like once per day, but I've got them.
I feel better when
Don't touch me.
it's just the like 1 page.
I see. Okay. Well, maybe in the future, just to make Bruce feel better.
Thanks. I just feel overwhelmed.
I see. Yeah.
So wait.
Yeah. Okay. No, I have to show you something. Ready? So you do not have to take notes on this if you don't want to, but pay really close attention. There's something called interval notation, which maybe you have seen before, but I don't think everyone has seen it before. So interval notation. So it's kind of another way of writing inequalities, a better way. So this is what it looks like. So I'm going to draw my number line. I'm going to draw a segment of the number line or something like that. Like let's say that I was looking at, so here's 0, here's 1, here's 2, -1. Let's say that I had an open circle to, and all the way over to infinity. How would we have written that in chapter 2? Like in the test we just really took, how would I write inequality for that, Charlie?
Yeah, if it's greater than.
Yeah, greater than, because it's going to the right.
So, 104.
Yeah, 2 is less than x, or x is greater than 2. Right?
And you just have to accept.
So that's how we write it as an inequality. There's something called interval notation that's going to be helpful in a couple of different contexts. And this is how it works. This is how I would write this green segment in interval notation. I have an open circle at 2. We always go left to right in interval notation. Open circle at 2, so I'm going to do parentheses 2, comma. That's the left endpoint. I'm going to look all the way to the right, except for it goes forever. So it doesn't really have a right endpoint. So I'm going to put positive infinity parentheses. That's how I would write that segment in interval notation. Let me show you another one. What if I just wanted if I have this segment, so like a closed circle at -1 all the way to 0 with an open circle. If I wanted to write that in interval notation, I have a closed circle. The way we show a closed circle in interval notation is with a square bracket. That means it's a closed circle. So closed circle -1, comma 1. What do you think? How do I close it? With a parenthesis, with an open circle.
Oh, good guys.
Huh?
Yeah,
That's
when
weird.
we start using like brackets and stuff. Like,
It looks ugly.
Guys, guess
What? I really like it. See,
Charlie's a bully.
the reason that I like it more is because with the X, we always had that problem where it's like, oh, I need to rewrite it as a mirror, or then we did the sandwich. Like for here, we'd have to be like -1 is less than X is less than or equal. Oh, no, I messed it up already. -1 is less than X is less than 1. Like that's how we would write that. We really get all the information right there without having to write the variable in it. Yeah, kind of. Okay.
Yeah, the seating chart in alphabetical order.
Yes.
How
Okay.
did I end up in front of Charlie?
Because I messed up. Okay. So, this is called interval notation. There are a couple rules with interval notation. So interval notation, like a closed circle, you use brackets, either a left bracket or a right bracket, depending on if it's the left endpoint or the right endpoint. Open is parentheses. We always go left endpoint, right endpoint, like left to right, always. We always go left to right. So this was -1 to 1. This one was 2 to infinity. And infinity or negative infinity always get parentheses. because they're like not real numbers, so they can't be included.
So if it's not going to another coordinate, it'll be infinity.
Yep. So let me show you an example of another infinity. Here we go, use purple. So what if we had this? Do you have a closed circle or an open circle?
Closed.
Closed.
Open, open, open.
We don't
We
close,
should
we
play
don't
with the
close.
brackets.
Okay, so if I want to write this in interval notation, left endpoint to right endpoint, the left endpoint is way over there. What's the left endpoint? Negative infinity. That's right, because it's to the left. So it should be parentheses, negative infinity, comma, 0, then bracket. So it's weird a little bit, but once it gets going, it's like actually really convenient.
How convenient.
Yeah, it's actually really convenient. Okay, all right, that's gonna come up today, so I needed to make sure that we'd all seen it before. So here we go. Ready? Okay, determining. Oh yeah, because it's like continued on. It's supposed to be like part 1. There's a whole. Anyway, we're starting on number 6. Here we go. Determining the domain and range from a graph. Find the domain and range of the functions represented by the graph. So here's the story. Domain is x's. It's left to right. And range is y numbers. So it is bottom to top.
Okay.
Because we always go small to big. And when you're looking up and down, the small numbers are down. big numbers are up. So for number 6. We learned a word yesterday, or there was a word on that like foldable thing for when the graph is used dots. Discrete. Discrete. Okay. This is a discrete graph. When we just have dots, I don't want to use that interval notation because that interval notation implies that I have all of the numbers in between the left endpoint and the right endpoint. Here, I just like have dots, like I just have whole numbers. So the way that we're going to show that, so my domain, I'll write a D for domain. Domain is left to right. What?
It looks very sad.
Yeah, it looks like a terrifying face. So the domain, we look left from right. And when I just have dots, I'm going to use these squirrely brackets. Like this.
Okay, wait.
Squirrely brackets? Yeah. A lot of practice. Even practicing. Kind of looks like a mustache, but like sideways. If you look at this sideways, it looks like a terrified person with like a
He's got a
little part
really
that's
big
going up,
forehead.
you know? Yeah.
Oh, that's like that.
Yeah.
What?
You know, we got it like this.
Stop messing with his
Okay,
face.
Okay,
And you put like.
Oh. we're being very serious. You guys are in trouble. My bad. Yeah. very
Sorry.
good. Super.
We
Okay.
should say it like Logan. I don't know.
So-
It was amazing.
X numbers, X from left to right, okay? So I'm gonna look at each of these dots, I'm gonna look from left to right, and all I care about is how far left or right they are. Here's another secret that I like to tell people.
Absolute
Okay.
value.
When I look at domain, I only care about left to right. I don't care about how far up and down they are. So like imagine taking like a freaking like press or something, I don't know, like,
Yeah.
and just like smashing all the dots right onto the X axis, like just smash them all around here. So it's like this dot would end up right there. That dot's already there, so it'll stay. This dot will end up right there. See what I'm saying? Like just like imagine me like and like smash them all down onto that. You know what I'm saying?
Like a little.
You have to make the noise. Okay. So the domain is gonna
It's
be
in the middle of the
negative
chat.
3, comma, negative 1.
Oh, wait, right.
Yeah, we have to write each like left and right.
Oh, hold
So you
up.
have -3, -1.
That's-
This is 1 and then 3. Yep. Close it.
We're
So that's the domain. We got all,
really proud of this one. Tell me that it's not a good look.
Really hard.
and I'm gonna erase those dots. Because when I go to look at the range, now I care about how far up and down they are. And I don't care about left and right. So we can imagine those, right, just like, right there.
Will there be any time that we can go? I'm just gonna
If I,
say.
they'd all end up at 0, 0, right? Like,
Yes, the principal is gonna
you
walk
only
by.
have one time,
Oh.
right? So domain is like, and the range
He's
is like,
gonna fire
got
you
it?
for being
Got
a
it,
math
okay.
teacher. He's gonna-
so the range, this dot can end up right there, this dot would end up right there, this one right there. Okay, So we're gonna do a squiggly bracket, yep,
Oh, the same.
because we just have dots, and we want smallest number first. So the lowest dot is right here at -2. That's the lowest dot. The next lowest dot is at 0, right?
What? Oh, yeah.
And then 2, and then
Am I
4.
on the right graph? No, I'm not. No, we're on.
Okay.
Okay, I'll figure it
Question.
Yeah,
Actually, never mind.
so let's go. Do you need one of these? Do you need one of these? The thing we're doing.
Oh, I left it behind her. Trying to get.
Oh, you can have another one.
out. I heard why you
Oh,
said
yeah.
Freaking stop.
Yeah, yeah.
Uh-oh.
Okay,
there's
So-
nothing on
oh, we're being very serious. Thank you.
it. You're British.
Charlie, stop getting us in trouble.
Not this pretty anymore. This is a continuous graph. I know, I thought it was off guard. This is a continuous graph. And like Aiden just said, I'm gonna go right here. So this one's gonna go here. All of that stuff is gonna like land in here and then it'll end right there when I pancake it down. Do you see that? Yeah, it would. Maybe our press is a little wiggly. Okay, I'll fix it. Wow, are you happy? Okay. Okay,
You can see stone blue.
so now this is where we want to use our interval notation, because now instead of just having just the dot, I actually have all of the, like, every space in between -2 and 3, is that right? So my interval notation for the domain, these are both closed circles. So we have to do a bracket -2.
Wait, how do you go from the
It's like, it would, if it was an open circle, it would literally like have a hole in the middle. Yeah, the same as if it was on the, like, our normal inequalities, it would have those circles. Okay, so this is -2 comma 3, and then a bracket, because they're both closed. One of those should be open, that'd make a better example, yeah.
Will we start using like bracket parentheses in equations this year?
No,
Okay.
I mean, you already do parentheses for like order of operations, but not,
Why
yeah.
not brackets?
you can use brackets, there's literally nothing, like, they mean the exact same thing in math.
No, we can't use brackets and parentheses.
Sometimes people, like, if you have like multiple things nested, like if you have like a parenthesis inside a parenthesis, they'll use a bracket, the outside one, just to make it look different. You normally don't use squiggly ones in equations. Anyway, okay, what's the range for this one? When I smash it going like, then it's gonna be from here up to here. So what's that gonna look like?
Bracket.
Comma to 2 bracket. Nice. Okay. That's our domain and that's our range. Cool. Cool. Okay, so on number 8, this is a discrete graph again, right?
Mhm.
On number 8, so we're gonna use the squiggly bracket since it's discrete. And we're looking for the domain, so we're gonna go right down to the x-axis. So it's like bam,
Oh,
Bam. bam, bam, bam.
I'm gonna do this.
I think I'm having one right now.
Yeah, exactly.
for the
It's gone. No.
That's a really good question. So Ava noticed that when we go to do the range for this one, like this dot and this dot are gonna be smashed onto the same dot. You only have to write it once. If you write it twice, that's fine, but you can save some time when you write it once. Okay, so our domain is like -2, -1, 0, 1, comma 2. Did I get all of them? That's the domain. And then the range, when I go to the y-axis, there's gonna be like here, here, and both of those get smashed there and there. So there's only 3 numbers we have to write in the range, because you don't have to write it twice if 2 dots get smashed to the same place. So the range is 0 to 4.
Can you go 4, 2, 0?
No, we always go smallest. to greatest.
Snazzy. Well, what the heck?
You're proud of your scribbler? Okay, on number 9.
I like to
So this is saying, this is an arrow, meaning it goes like out and up forever,
Okay.
okay?
Oh.
So the domain, this is continuous, right? So, because it's not just dots, so we're gonna use the bracket thing. So domain, if I were to go onto the x-axis, there's a closed circle here, and then we go this way, and that arrow means it's gonna keep going that way forever. So what should our interval notation look like?
Bracket, negative, comma, or no, wait, we're doing negative two,
Infinity,
and parentheses.
and then parentheses, we always put parentheses with infinity. Nice, okay, and then the range, we go this way, it's like, this is the thing you have to be careful about, so it starts here, this, like, since it's still slanted, it means it's gonna keep going up forever, it's just slow, so it really is gonna keep going up forever. It doesn't stop right there at like 2 or whatever. So -1,
There we go.
comma, infinity, will have parentheses.
Oh,
Yeah, so that is gonna keep going up forever also. Okay, numbers 10 and 11, we just need to look at really quick. These can take us through. Questions on this? We're okay with the,
Yeah.
got it. Okay,
I'm gonna hire you to teach your beatbox. Are there people on the Zoom call hearing this?
yeah, definitely.
It's like worse.
Although Lincoln left, we probably couldn't stand it.
Well, I wanna leave, cause
I actually have a friend that is actually like a professional beatboxer. What's cool.
Wait,
His name
really?
is Parker.
Would he come to
King.
class?
No, he lives in Idaho.
Oh, would he drive to?
No, probably not. But anyway,
yeah.
he's like a professional beatboxer. Okay, the function y equals -3x plus 12 represents the amount in ounces of Gatorade left. Okay, what's the best flavor with Gatorade?
Blue.
White.
Light blue, it's light blue. That's the best one.
Orange.
Laser green.
Laser free.
That's white.
Oh, no, you're right. What's the
No,
light blue
You
one?
don't call, no.
Light blue one is best.
Laser green is.
Yeah, that's what I thought.
Except you don't
not. It's
classify
blue.
Right, right.
I mean, no, it's just white.
Okay,
White
So-
is-
I haven't learned all my colors.
the function y equals -3x plus 12 represents the amount in ounces of Gatorade left in the bottle after you take x number of gulps. I hate that word. X number of gulps.
I
Okay.
feel like that sounds like we're wrong.
So it says identify the independent and dependent variables. I think we did this for like our Bellinger, like the first week or something. So what would the independent variable be? What do you control? X, it's normally X, so like you control how many gulps you have taken. Whoops. Okay, identify the independent variable, number of gulps,
Well, but what if you're on an IV trip and you don't have a choice?
gross.
What is it called?
Number of gulps. And the dependent variable then is the amount of Gatorade left.
Why can't it be like gold? I don't think it's gold.
You know, it's-
Negative gulps.
Ew.
So that's a good, that's a good question. So Riker said, what if you had negative gulps? Notice it says our domain is 0, 1, 2, 3, and 4. Yeah, well, so like negative is not, we would say that that's not in our domain because that doesn't make any sense to like throw a Gatorade into the bottle. You probably wouldn't be like after that question. So it says the domain is 0, 1, 2, 3, and 4. So these are like the possible number of gulps you've taken. So it says, what is the range? So the range is going to be like, what are the outputs? When I put 0 in, so when we have taken 0 gulps, how much is left? How many ounces? 12 ounces is left, right? Because we plug 0 into the equation, we've taken 0 gulps, we have 12. When I've taken 1 gulp, apparently for every gulp, we lose 3 ounces, so there'd be 9 ounces left. Gross, okay? When I take 2 gulps, 6 ounces will be gone, so there'll be 6 left. 3 gulps will leave us 3 ounces, and then after 4 gulps, we have finished the bottle of Gatorade. There's one thing I'd like to change, and maybe Logan's about to say it. What do you think, Logan? I would agree. We should switch the order so that it is smallest to greatest.
Oh, now I have that in my head, reversible. I don't.
Negative goal. Okay,
Okay, but if you had-
here's the thing though, here's the thing. Negative goal, the other variable is amount left in the bottle, and if you negative goal, then like the bottle's already full. So like it wouldn't change amount of the bottle, you just throw it up all around the bottle, there'd still be 12 ounces in the bottle. So, okay,
Wait, it's like,
you know what I'm saying? Just
I
saying.
think there's always a little gap.
Okay, this is all being recorded right now. Morgan's at home like, what is wrong with everyone? She misses us. Okay, the function A equals -4B plus 14 represents the number of avocados you have left after making B batches of guacamole. Identify the independent and dependent variables. So what do you have control over? The number of batches you make or the number of avocados left?
Both.
The number of batches you make.
No, it's both, because you can go buy different amounts of avocados.
bet.
Yes, that's right.
Go buy the
So-
state of California.
There is not infinite amounts of avocados.
Yes, there is.
There is a number to how many avocados are here on the.
They're
Okay, yes,
always
but we never,
wrong.
we never specified on, or, we're not covering.
Okay,
Okay, still though, there is
Just
a
go
number
read
of.
Go.
Is it?
I don't get why.
Okay, I
avocados-
didn't-
You couldn't buy any avocados.
Okay.
from other-
The domain is 0, 1, 2, and 3. What is the range? The range, when we've made 0 batches of avocados, how many avocados? Or we've made 0 batches of guacamole, how many avocados do we have left? 14. So apparently it takes 4 avocados to make one batch. Oh my gosh. I would botch it too, okay. So 14, and then when I make one batch, that's -4 times 1, plus 14, so that's 10.
Hey, well,
And then-
you gotta write them the other paper.
It should be 6. Oh, yeah.
No,
Six.
don't write them out.
2.
You can calculate them. Three.
Oh, yeah, you can just calculate it backwards. So it's like this,
Yeah.
2, 6, 10, 14.
Wait.
What about
is
your
it not
negative amount of
incorrect to
avocados?
do it,
No,
uh,
When you pulled it in your finger.
what other one?
So you write it.
Grammatical.
Greatest and smallest stuff. Okay, all right. Let me show you. This is what we got. This is what we got.
Wait, no, do what Mr. Anderson does.
Yeah, just throw it at us.
Okay.
Wait, I'll show you,
I'll show you how
he does it.
Mr. Anderson.
Is the English teacher?
Yeah.
It's like, he's just like, it's just like, hey, we're gonna have a worksheet now. And he pulls it up and he like leans back and he steps into it. Like,
Listen, I'm tempted, but also,
you
I
got all
feel
of your
like,
left foot.
here's the thing.
You
I don't really care about you guys, but like, what if I got a really bad paper cut? Okay,
It's not that big a deal, just throw it in. Please do it. Please. Please. Please do it, it's so fun. If we get a paper cut, we won't blame
You'll
you.
be my favorite.
We'll blame the paper.
We won't blame it on you. You gotta throw it right so they all spread. You gotta throw them like straight. Practice throw, practice throw. Straight. You gotta grab
Wait, how are
it,
you supposed to?
step, and throw. Like a baseball. Yes.
There, yeah.
That's what, do it, do it. Yes.
I'm scared.
Just do it. Just do it. Just do it.
What?
Did you count them out
No.
first?
Just do it. It's okay. It's okay. The extra ones just get picked up and put on. Do you need a pregame thought?
I'm scared. Yeah,
Just do it. Can I do it? Let me look one up.
Okay, okay.
Just step forward and throw.
No,
Just do it.
come on.
We got this.
Just do it.
Yes.
Do it. Go,
Yes,
go,
yes,
go,
yes,
go.
yes, yes,
You're
yes,
trying to do
yes.
reverse psychology, and it's working. Okay, here we go. Oh, I'm scared.
That didn't really work.
Now you know what
I
to
think
do.
she threw it a bit too hard. Okay, so
Does it normally spread more?
Yeah,
Only like.
Really?
Yeah.
it doesn't turn into one.
Alright, have to go back.
You just got that. You got this.
Yeah, oh, that's a good idea. And like slowly, a gradual release. Okay.
Well, you have to,
We'll
like-
take this again tomorrow. We'll back to you tomorrow.
Yay.
you should let the students show you.
Let's look for it.
Yeah, he likes to watch us bend.
Or
What
wait,
you could do is you could just get like a fan and you just
What?
set the.
Maybe like with them, so it's like.
Oh, you can
easy and you drop it and then it falls off your desk. Kind of fun.
She can do it. Wait, I can see mine.
Because Mr. Nichols will come up to us and he'll be like, here's the papers, you go like this. And it
Everyone
like
looks so
falls off your
dumb.
desk.
Everyone looks so dumb.
Oh.
That was good.
That
That was good. Yeah, because you didn't go to the back of the room and slide against the wall.
I just stopped the